Hello viewer! Today I wanted to show you, as an extension to my last video on physics rigs, how physics grabbing works in virtual reality. How do you get an object like this device right here to be properly configured such that the player can grab on the magazine, the barrel, any part of this tool? And it all starts with physics grips, and this is a system that works on any sort of physics rig. So you might have a rig like Half-Life Alyx where the hands are kind of just floating in air and not connected to the body, as well as something like this, where it's a ragdoll with an arm and a forearm that allows the player to have a physical connection from the hand to their body. It works with anything sort of physics-based. And we have these physics joints. So what is happening here is we have the physics joint of the player's hand, which right now is being represented by an invisible cube. It has a collider. And obviously we can touch this object, but we do a little bit of math to get from this physics cube to rotate it down to this surface, and then form a physics joint. And a physics joint is essentially a force between the player's hand and the object that it's touching at this location to keep them together, physically. And it can kind of break with this, because it's not very strong. If I pull my hands together, you see the hands kind of go apart a bit. That's a sign of a weaker joint. But this is just one little joint on the surface, and you have to put, as you see here, a ton of joints to make it work properly. And that's not ideal, because what if you have to model and joint up something like this and put a bunch of grips on a massive rocket? It's not going to work very well. You need some way of generalizing the points on objects, so you can take a complex or large object and then put on a number of, like an infinite number essentially, of physics points to grab at. And the solution I've found to this is to use generalized grip surfaces. Here we have 4 grip surfaces based off of Unity's primitive objects, where we have a primitive cube, sphere, capsule, and then this little line, which I'll call primitive, and there's a few more, but they're really encapsulated within these 4 objects. So, on this sphere, not this sphere, on this cube, if I put my hand close to it, you'll see that a sphere appears. This sphere is a physics joint, kind of like on that cube there, that is then being teleported beneath the hand at the plane of the cube, which allows me to grab on the entirety of its surface. And this can obviously be used on any sort of wall that might be climbable, but it also allows for the manipulation of more dynamic physics objects. But at the corners of this cube, I also have a corner grip, and obviously there's a lot of corners in real life. Just look at those ramps over there. Pretty much every solid manufactured thing will have some sort of corner. So it's also quite valuable. Oh, and this cube sort of works on the corners by teleporting a joint to the line along this edge, which is, it's actually represented by a cylinder for detection. And at the center of the cylinder, the grip point teleports, and then the rotation is decided by the hand. It either will go on a direction like this, where the palm is on this side, or will be the very opposite, where the palm is on the top, because obviously both of those are possible whenever there's a corner. And an important object of note is that for the grips and for the plane, it's very important to have some sort of gizmo that represents where they're going, because otherwise it is very difficult to tell how you are supposed to rig the object, what kind of rotation they're supposed to be at, because you can go on the other side where it can be upside down, or with this it can be like, you might grip and it might be inside of the object. So make sure to include that if you're making such a system, and expose it to modders if you have modders. Then over here, we have a capsule. This capsule, it's useful for any sort of railing, any sort of cylindrical object, obviously. And in fact, we have these, over here, sticks, which are essentially made of a number of capsules, all put together in one object. So they're very easily represented with this. With just 3, I think, no maybe, I think it's 2 capsules, the entire length of this object can be grabbed. There's no special grab point at, say, here or here. It's just all represented with one trigger, one collider that allows it to be grabbed properly. In fact, the entirety of this rocket over here is represented by just one single cylinder grip. So I could climb from the bottom over here, the entire length of the rocket, with just my hands all the way to the nose cone with just that simple cylinder grip, which shows the power of these sorts of systems, because instead of placing what would probably be millions of points Instead, I have this one-cylinder object that is both more processing intensive and much, much easier to work with than it would otherwise be with an individual point system. And it's currently escaping us, but over here is a sphere. And the way it's calculated with a sphere is you take the radius of the sphere and then go up and take the tangent at the surface of the sphere, and rotate the hand like 90 degrees into whatever direction it wants to be. And what you get is a sphere grip, which can obviously be used on a number of physics objects. So something that's might be clear to any user is something like this would be useful with such a grip. But also more geometrically complex objects like this rock can also be represented with a sphere grip. It doesn't matter that it has to be exact, it matters that it looks about right. And this looks about right, it breaks right here, but it's very simple to set up, and that's what's important, because timeliness is important in making a product. Otherwise, you won't have a product. Oh my god, it went through the floor. That's not my fault, it's physics setting on the object. I should really bump it up, it just takes more processing power. And the fourth grab surface we have, although it's not really surface, is this linear line, which is very useful for any sort of tool you have, because it doesn't interfere with whatever hand animation is being used. What I have right here is a very simple hand animation. It's not even like bending oh my god, bending the hand fingers properly. They're just rotating like 45 degrees every single joint. It should be going towards the palm, but it's not, so it's not quite right, but it works. Oh my god. The grip joint is super messed up on that, or not the marker that's being used. But it doesn't matter, it works properly. And putting all these together is how we get these more complex tools over here, where, say for the barrel we have a cylinder grip, for this magazine we have a bunch of corner grips, and then for the handle we have one of those individual grips that we saw earlier. And this can be used to represent a number of objects. So this is another object that is represented using, what, like 4 plus like 8, 9 triggers to make this relatively geometrically complex object, although it's not really, into a grabbable, usable thing. It's very easy to set up so long as the grips are there, which they are. And that's about it for the fundamentals of physics VR grips. The next mechanic I'll likely show off is how multiplayer functionality works in VR. So if you're so inclined and you want to check out physics VR multiplayer, look out for that in the future. I hope you found at least part of this video interesting. So, goodbye and have a blessed day.